Good afternoon, good morning, wherever you are. Today we have a very special guest, Dagwe. Me and Dagwe, we used to work together at Pivotal, and since he has moved to join Kong, which is an excellent API gateway. So at Pivotal, obviously, me and Dagwe, we were working on cloud native platforms like Pivotal Cloud Foundry or Tanzu application services, as it is called now, and many other things in the Kubernetes world as well. So very warm welcome, Dagwe.
Hey, thanks, Yuki. Thanks for having me in this great event. Really appreciate the opportunity to collaborate with great old friends and colleagues. Yeah, I joined Kong 3 years ago as the first SE in Asia. So yeah, over the past 3 years, the company has gone through some hyper growth, has come a long way. I believe the Kong is very different from what you probably knew a few years ago. Yeah, so in this today's session, we will explore how these two solutions actually can work together, right? I mean, to really simplify application development, right? In a distributed world.
So that is extremely interesting, right? We worked in the application layer and you moved up to the API layer and I joined Yugabyte. And as part of that, I moved to the data layer. It's super interesting. Both are distributed technologies. So I'm really curious, what do you see as the common challenges in the space that you are in right now, the API space?
Yeah, so from an API perspective, right, I think today there are many different moving parts, right? So I think we both come from application background, right? Back in Pivotal days, so we know. I mean, with microservices architecture, developers can choose any language or framework to build their microservices, right? So it's no longer just Java or .NET, right? I mean, you can use Node.js, you can use Python, you can use Golang. There are so many choices. So developer can choose the best language, the best tools they think that is the best for the job, right? And then at the same time, in the infrastructure layer, there are so many options. You can use any public clouds. You can use virtual machines. You can use Kubernetes and containers and so on, right? And then there's a lot of complexity involved in the infrastructure management as well. So in summary, basically they're just moving more pieces to manage, right? While you're building microservices, they're running containers. Now we used to have a few big monolithic systems. Now there are hundreds and thousands of microservices. So this will basically impose a lot of challenges, not just to developers, but also to the operators, right?
Yeah, this is really something that we are very familiar with, right? Over the last few years, we've seen cloud native things getting more and more popular. So how does Kong actually help solve some of these challenges, Dagwe?
Yeah. So first of all, I think Kong is a cloud native solution. That means it's super lightweight and highly performant, right? Um, you can run Kong in a container, in virtual machine or bare metal, doesn't matter. It's super flexible. And then secondly, right, from a developer perspective, a lot of the policy enforcement, now you don't have to manage this within your application, right? No matter what language you use, you don't have to worry about like how to handle rate limiting, how do I integrate with API identity server for authentication, how to log the request, because we have all these basically plugin already built out of the box to help developers. So you can focus on building your business logic while Kong Gateway can help you to manage all these policy enforcement. More importantly is, especially in a decentralized architecture, you have the flexibility of running multiple gateway, right? You can have an external gateway, an internal one, you can deploy Kong as an ingress controller. So it's super flexible to help the basic developers to solve those kind of challenges.
Yes, that I think I have experienced somewhat when I was working at Standard Chartered, and I had the opportunity to work on Kong itself, and I know like SEB is a big customer now. So how Kong has evolved since? Like I'm talking about something like three and a half years ago, I believe.
Yeah, I still remember, right, when I joined Kong, you say, oh, you are joining a great company, right? So you really like the technology. I still remember that. It was just like yesterday. Yeah, actually, Kong was started as open source API gateway, I think about 6 years ago. And then since then, right, Kong has very quickly gained popularity and mindshare among developers because developers are looking for a cloud native solution and there wasn't any, right? So Kong was that solution back then. So ever since I joined the company over the past 3 years, the company has grown a lot and evolved as well, right? So we are no longer just an API company, right? So API Gateway is still the core and foundation, but we are building a complete end-to-end services connectivity platform that covers API Gateway use case, Kong ingress controller, service mesh, together with many other tooling and automation and so on and so forth. So this is basically a quick overview of the platform we are offering today.
Oh, that is really a very well evolved portfolio now. Yeah, in fact we came up with this reference architecture, right? Wherein we provide the global data service through a Yugabyte DB, which is a distributed SQL database, and the distributed network functions like an API gateway, load balancers is covered by Kong, including the GSLB. You want to talk through some of that?
Yeah, exactly. This is very common as well. We see from our customer deployment, usually they are actually looking for multi-DC or hybrid cloud deployment, right? So Kong can actually be distributed across multiple data centers or in different cloud providers. And then Kong, as you rightly point out, right, Kong can be used as a load balancer, not just at the API layer, but also at the TCP layer, right? So if you need a load balancer in front of Yugabyte database, so you can do that as well. Actually, interesting enough, right? I mean, Kong requires a configuration data store. So we support any Postgres compatible database. So we can use the Yugabyte, as a configuration database as well, right, to support a multi-DC deployment. So in the next demo, I actually will show you in action is basically mirror something. This reference architecture. So shall we? Really? Yeah, shall we?
Yeah, let me get popcorn.
All right, all right. So now will be a demo time, right? Let's show a live demo to show you how this will work in action. Yeah. So in this demo, we are going to use Yuga Store sample application from Yugabyte. So this is a Java version, right? So basically, it's using a microservices architecture. There are multiple components. Some of these are API-based. And then there's an API gateway. Data is stored in a distributed Yugabyte database. So let's just look at the sample application first. So I have a EC2 instance running on AWS. So this is the IPJS. I've already installed Yugabyte here. I've deployed the sample Yuga Store application. So when I access this IPJS, this is how the website will look like, right? So basically, I can search for books, the music albums, and beauty products, and so on. So behind each of these, when I click on the page, basically it's calling the API. Now, what we're going to do is you have the data being managed here in Yugabyte database. We are going to put Kong as an API layer to secure the APIs to retrieve books, music albums, etc., right, from the data store. So just for demo purpose here, I have installed a Kong on the same VM. Of course, the whole setup can be deployed in a Kubernetes service if you have an EKS cluster. So here, basically, this is the management interface for Kong. So interestingly, Kong uses a database to store the configuration. We support any Postgres compatible database. So in this case, just to make it simple, right? We already have a Yugabyte running, so I'm going to use the same database to store configuration for Kong as well. So basically, Yugabyte database will serve another purpose. So let's just go to have a look at the database here. So I created a user called Kong with a database Kong, and you can see the tables are already provisioned. So basically, the configurations such as the admin user certificates, consumer, all these entities will be stored in Yugabyte database, right? So for example, here we have registered 2 services, and if you do a database select statement, you can see these two services actually stored in this services table, right, in Yugabyte. Okay, now, so we have registered this particular products endpoint, right? So as you can see, it's running on the same machine, so I'm just using localhost. So this is pointing to the APIs, right, behind to retrieve this. So once I register the service in Kong, I will provide a route object for the users to access the service here. So basically, we can have a look here. Follow the same path. So now I can actually use a API access, right? So I can basically 8000 is the proxy port for API gateway. So I can say, okay, let me retrieve the books, right? So now the request will go through Kong, all right? So let's make a call. As you can see, you'll return the same results here. Right? As you can see from here, you actually see the same results now written in a JSON object format, and then will be displayed by the UI application, right? Okay, so this is a simple proxy, right? So now what is interesting coming to next is as a gateway now we can manage the access and secure, right? So there's a lot of policies we talk about here. So for example, I have enabled a rate limiting plugin here, right? So basically in this plugin, basically I've put in the policy saying there's a limit of 10 within a window of 60 seconds. So that means you can only make API requests, 10 API requests in any minute interval, right? So since this plugin has already been enabled, you actually see there's already some headers, right? When I access, we are keeping track of the rate limit as well as how many API calls have already been consumed. So if you keep calling this, you will see the counter will just continue to go down as you are making continuous call. And so this is to basically avoid like making users are making too many requests and causing the website to go down, right? So kind of prevents kind of DDoS attack or give the end user some quality of service. Another thing we can also do, right? So besides rate limiting plugin, there are many other policies as we talk about, right? So you can also enable authentication to check user credential, right? So user can pass in their job token or key or integrate with third-party identity solution. There are other policies such as IP restriction, costs, right? You can enable costs without changing your application code. We have added in support for to integrate with OPA, and then you can do many other things, right? So maybe one more thing we want to do here is, okay, let's enable some caching. So you can imagine, right? If every time I have to make a call to the API, right? And the data don't really change that often, right? This product catalog usually will only update once in a while. So can we cache the results here, right? So if you notice here, because, okay, let's just look at the, okay, as you can see, right? It takes about 300 milliseconds, right? For the typical response time. Let's make another one. Yeah. So under normal situation, it will take roughly 0.36 seconds. Of course, for more complex APIs, it may take longer during peak period. It can even become slower. So let's add in a caching layer here, right? So can we enable a proxy caching plugin here? So I'm going to just say, okay, of course we support Redis as an external cache. In this case, I'm just going to use a memory strategy where Kong will cache the results locally, right? So once I enable the caching strategy on the same API, so let's see what happened, right? So first of all, okay, you actually take a bit longer, right? Reason being now is connect. You need to actually check whether the result is there. If not, right, actually you can see now there's an additional header being added. So it generates a cache key based on the request. And then first request is a miss, right? And it takes some extra time to update cache. So, but subsequently, right? So since the data is the same API request, if I try to call the request again, you can see The next request is hit, okay? And then you can see the response time is reduced to 7 milliseconds, right? So it's a big performance improvement. So what is more important is that now with a caching layer easily configured at the API gateway layer, so basically you can reduce the round trip time, right, to your microservices and database. And of course, there are many other policies you can, as you can see, you can stack the plugins. So on the same API, if you have multiple policies, you can actually enable other things such as you can log the request. You can also do some authentication. Okay, maybe one more thing just want to just quickly show here is that once you onboard the API, another important thing is you need to publish the API and then engage developers, right? So that developers will have a place to discover what APIs are available. They can start building new applications. So for example, here, once we expose the APIs, right, other users, right, maybe now people can actually sell your books and products from other channel, right? It could be a third-party application, could be a third-party e-commerce application. So, so we need to basically make the APIs available so that developers can actually onboard themselves and then doing some testing. So that is basically what the dev portal is about. So I've enabled a developer portal here for this particular workspace. So if you go in, you can see you can basically publish the API spec. So let me just switch over to the dev portal. So we have an editor here. It's like a content management system. So basically, you all upload the API specifications here, right? And then based on the API spec, you will generate the API documentation. So when developers come here, and then they can, of course, they can sign up themselves as a developer. So here I create a user for myself. Once I log in, I can actually browse what the APIs available in the catalog. You can add some tags, right, to do some filtering and search. And then I can say, okay, let's look at any one of the API. So based on the spec, you'll generate this documentation automatically. So as a developer, I will know, okay, how what are the operations available for this API? What is the URL? I can actually say, try to look at how to actually call the API if I'm using different language. And if the API is actually listening on this particular address, I can actually do a test, right? Maybe not really delete. Let me try again. So let's try this out, right? And then you'll basically connect to the API and then give you a response back. So developer will be able to actually build the application knowing how to make use of the APIs. Okay, so I think that is just really a quick walkthrough, basically to show you, I mean, using the sample application to show you in action, right, how Kong Gateway can help to secure the access layer, while the Yugabyte database can provide a scalable data layer, right? So how these two can work together. All right, so that was just a quick demo. Okay, we have talked a lot about API layer, right? Maybe let's change gears a bit. Yogi, what do you see as some common challenges at the data layer?
Yeah, so data layer has its own challenges, right? So if we look at broadly at the data layer, you have legacy relational databases and non-relational databases, and there is a sort of a hybrid thing around the cloud provided databases. Now, each one of them has their advantages. I started my career with the relational databases, so all sorts of ACID transaction capabilities and consistency and the relational data structures and everything was great in there, but they had challenges in scaling, right? Which is kind of the need of the hour when it comes to microservices, even with APIs, right? But those were the challenges with the traditional databases. In came the non-relational databases. You're talking about things like Cassandra's or the MongoDBs of the world. They would scale really well. They would provide you with a good native replication capabilities, but they lack the consistency that the relational databases actually provided. And the cloud databases, they provide you ease of automation around the infrastructure pertaining to it, your D2 operations, manageability, all that is great, but they have their own set of trade-offs. They don't run on on a different cloud provider. Some of them are not even open source. Some of them don't even have the SQL construct, right? They use their own API. So these trade-offs, they end up actually costing you a lot, you know. And this is exactly where Yugabyte DB is sort of working. We are providing the relational, consistent, familiar structure when it comes to the data layer, with the resiliency levels and scalability levels that you have seen with non-relational databases. Those two things sort of coming together, and also having having the ability to future-proof your investment, because it's an open source database. It runs on any cloud, and even in a hybrid model. So that's where the challenges that we are seeing in the data layer are being addressed by Yugabyte DB.
Yeah, I remember back in Pivotal days, right? We also have some great data solutions such as Greenplum and Greenfire. I know both Greenplum and Yugabyte DB are based on Postgres. How are they different?
Oh, that is actually a very, very good question. See, the Greenplum or a lot of modern age databases that we have seen in recent times, probably last decade or decade and a half, a lot of them are actually working in this area that we categorize as OLAP, or industry actually categorizes that OLAP, right? Online analytics processing. There, the concentration is more on working with huge amount of data, big data, right? But the transactional space is still very, very niche for these products. So Greenplum was an OLAP system. Yugabyte DB is an OLTP system. It provides you with the SQL and NoSQL kind of constructs, which is quite unique. Plus, it's open source. So if you see here, we are in the top right of the whole process of the whole ecosystem. And one more thing, Yugabyte DB is actually platform agnostic, infrastructure agnostic, actually. So you can actually run it on VMs, you can run it on bare metal, and you can run it in containers, Kubernetes, actually.
Oh, really? I actually quite surprised to hear that, because I know for application or APIs, right? I mean, it's very natural to run them in containers, but a lot of customers, they will prefer to run database in the virtual machine, bare metal, or performance reasons, right? So what are the benefits if you run Yugabyte DB in a Kubernetes environment?
So Kubernetes has basically emerged as a common infrastructure API, really, right? You can run your application, you can run your data services. We have first-class support for Kubernetes, right? You can run Yugabyte DB on all sorts of Kubernetes, cloud-provided Kubernetes, some of the more popular distributions like OpenShift and Tanzu. You can run it on them. And as a matter of fact, we are doing extensive testing with one of the regional cloud providers, Tencent. Anthony actually spoke at length about it yesterday, right?
Yeah.
We tested it on their Tencent Kubernetes engine, TKE, and it works really well. So it's all very powerful, actually.
Yeah, that's really good to know.
And another benefit of Kubernetes is the level of automation it brings in, right? As I mentioned earlier, it's practically emerged as an API for the infrastructure. So we have first-class support for Kubernetes through Helm charts, through the operator, even the operator hub if you're in the operator hub ecosystem, and also we have a Rook operator. And in terms of automation, right? At its core, you can leverage the native capabilities around the Kubernetes itself to provide great degree of automation. So things like if you are into GitOps model, wherein you push things into Git, gets synced into the cluster via things like Argo CD or the KApp controller in the open source ecosystem, and each of your component in the cluster is sort of synced through that. So this actually gives a very powerful way to automate a lot of regular things, backups, provisioning, upgrades, things like those. We have the Yugabyte operator. We have the Yugabyte a portal for doing some of these things in non-Kubernetes environment, but in Kubernetes world, this is something that you could use. So in Kong, what do you have to support the automation or the CI/CD aspects of the customers?
Yeah, absolutely. I think we are very much aligned, right? I think the automation is the only way to go, right? To manage application at scale, not just I mean about applications, but all the layers, right? Including database layer as you described, but also coming to API layer, right? So when you have API specification, usually in the format of Swagger files, right? The developers can check in the Swagger spec as part of the source code, right? And then that can trigger using GitOps or any other CI/CD tools to trigger the flow where you can automatically publish this API documentation onto developer portal. You can even automatically provision the policy configurations, right, through YAML files, right? So, and then you can propagate this, especially when you have runtime deployed in different environment, right? The same configuration from the same single source of truth can be propagated to multiple runtimes, right? No matter where they run. Another interesting aspect, right, when it comes to API management is really the way how customers manage identity, right? So very often we see customers using the API gateway together with identity provider. OpenID Connect is the common standard. We use the support. We have a plugin that can integrate with any OIDC compliant providers such as Okta and so on, right? And I heard you are working on some interesting projects and taking this one step further, right? So knowing the identity, now you can really handle the data distribution across different geography, right? Can you share more details about the project you're working on?
Yeah, actually, we do. And wherever I see like things like user data, the bulbs go off because of my background in the financial industry and all sorts of legislation around GDPR these days and like PII data. So Yugabyte DB supports a variety of replication capabilities and geo distribution capabilities. So in cluster, we support synchronous replication. That is really what gives it the power, the zero RPO downtime and a very minimal RTO. And we also support asynchronous replication across multiple clusters. But something that really caught my attention very early on with Yugabyte DB was the geo partitioning at row level. So this is where you can actually have a particular row being stored in the servers which are parked in a certain geo. So imagine this, you have your user database, a single user database globally, wherein the users for EU have their data sitting in the EU servers, and US users have their data in US, and Asia users have their data in Asia servers. And this is done at the database layer. I recently wrote a blog about it. It was like a very interesting blog that I have written after a long time, I would say.
Yeah, it looks really interesting. I definitely will read more about your blog post. Very interesting use case. I think very much applicable to a lot of financial services customers, I believe, right?
Absolutely.
All right.
Yeah, so this is also fascinating, really. I mean, I'm really happy that we had this conversation, and thank you very much, Dagwe, for your time today. I'm really looking forward to a closer collaboration moving forward. Thank you so much for actually today.
Yeah, I think we are really just scratching the surface, right? There's so much to talk about and catch up. Really looking forward to closer partnerships. Thanks for the opportunity for such a great event, right? So with that, I think we will wrap up our session, and we will open for any questions.
Yeah.
Thank you so much.